Yorana Kuru, everyone. This is Dr. Dale from Rapa Nui. Right now I'm almost on top of Maunga Orito. Maunga Orito is located very closely to the island's runway. So you can see it starts here by the ocean. There are the fuel depots that all the fuel goes into. The runway goes from one side of the island all the way to the other side. Farther to the south, you'll see the remnants of Rano Kau, which was a huge strato-complex volcano. But if we move slowly to the side of Maunga Orito, what we're going to see is heaps and heaps of obsidian. So, if you are interested in Game of Thrones, this is where dragon glass comes from. No, just kidding. Rapa Nui has 4 obsidian deposits. All of them are related to the volcanism of Rano Kau. But here at Maunga Orito, the obsidian is very fine quality. It does not have many inclusions, and it's really good to reduce. So in archaeology, a very important way to understand how people used stone tools of the past is to figure out how did they make them. What was the operational sequence or the chain repertoire of making a stone tool? So what I wanted to do today was go through a process of reduction, starting at the raw material, which are these obsidian outcrops. From there, we'll go to things from like cores to reduction to the hammerstones that are being used, and we're going to go through this whole process to get us a stone tool to be used in the past. So right away, you're going to see that there's multiple obsidian deposits. These are called pu, or sort of pits, that a lot of these obsidian cores have been put into. Now, this process continues for about 100 meters behind me of just this pu process. I started here because these are some of the biggest. There's my 1.5 meter stick in the middle of one, so you can just see the size. So let's investigate one of these obsidian sort of pu. And it all starts out by finding the line or the microstratigraphy where the obsidian is coming out on the surface. Usually when this material that becomes obsidian is inside the volcano, we can call that rhyolite. But as soon as it gets exposed to the surface and cooled very quickly, that lava, it forms this sort of crystalline material, which we all know is obsidian. And obsidian's located all throughout the world, but in Rapa Nui, we're really lucky because we have those 4 deposits. So the first thing I might want to do is maybe I find myself a core that I want to work from, like this one. All right, so here's a piece that's been removed. I can notice on some of the margins that obsidian is definitely coming out and showing itself. Now, sometimes you could use this sort of material on your tool as a scraper. So some obsidian tools have remnants of this sort of harder cortex that's really good for scraping. But to be able to reduce this stone, I need something harder or more consistent. And here I can find my hammerstone. And I just found one of these just down the way up here. Here's what we call a poro, or a beach-worn stone. Basically, these are stones that are close to the ocean that get rolled up and down over time and form this nice, smooth sort of surface. I looked on one end, and I definitely saw a lot of use where this is being used to effectively break down and reduce that core. And once I take off that cortex, the outside, I start to see beautiful cores like this. I can see multiple flake scars where larger pieces of obsidian were removed, right? And that helps us because we can see what type of technique was being used to make the stone tool. What they're really looking for and after are getting beautiful flakes like this, which are just complete obsidian sort of preforms of something that would be like a mata'a, which is sort of a bifacial tool. But on the back side, it didn't break the way they wanted to because it looks like it still has a little bit of cortex. So they didn't seem to like this piece and they left it behind. Now, in that reduction process, you create a lot of smaller little pieces. We call this débitage, is sort of a fancy French word. And it's just all the little bits and pieces of that reduction process that end up getting next, that end up being left next to the pu in this reduction process. Now, sometimes flakes are used immediately. These are really good for use as scrapers, or to sort of descale fish, to cut vegetable materials, to weed your garden. So most obsidian that we find was probably used for agricultural reasons. And that's the main reason why when you walk the sites on Rapa Nui, there's obsidian everywhere. Is because these individuals, in some places, they would have their core and they would keep that with them. And then once they came into a job that they needed to do and needed a specific measurement, they would eye it up. They'd find their hammerstone, they'd knock that piece off, they would use that to clean their garden, to peel, and then once done, they just sort of chuck it on the ground. Because they have more obsidian, they can go back to their core, they can go back to taking off another tool, and the process just continues. So it's a little different than what we see with basalt stone use, that material seems to be curated a little bit longer. There just seems to be much more obsidian to be used. So I think that when you really start to understand how stone tools were made, it gives you a better idea of the social complexity of stone tool making. And on Rapa Nui, we believe there were excellent specialists. They were called Tanata Maori Anga Maea, or Maya Toki, or Maya Paenga, and they were all different specialists working on their specific raw material to make the tool that they needed to make. But when you come out to places like this, it's very important to walk slow, to take your time, because if we don't have sites like these, or we don't protect sites like these, we're not going to know how the people lived to make the moai and transport the statues, because it's these little pieces of the puzzle of the past that we need to put together to understand this amazing culture found in the middle of the Pacific. So points of emphasis of this video is going to be obsidian. We're going to talk about reduction, sequences, cores, preforms, debitage, and artifacts. Yorana Korua.